The diameter of the observable universe spans a total of 93 billion light-years across. Within this daunting expanse of starlight and wonder sits the Milky Way galaxy, merely a pinprick of light in comparison. And even smaller still is a humble blue sphere, called Earth, our home. My name is Daniel Danielson, and this is Space Stuff. Wait, Neil, space stuff? Oh, f*** all. Reaching backward through eternity, the sum of existence resided in an infinitely dense, infinitely hot singularity of matter, drifting through nothingness before time had even begun. And then, 13.8 billion years ago, whether by chance or design, two particles within this singularity collided with enough force to trigger the first ever chemical reaction, the Big Bang, which perhaps should instead be referred to as the Big Explansion. In a trillionth of a second, the infinitely dense singularity expanded faster than the speed of light, and so the universe was born. Neil, could we back that up a bit? I think I might have said explansion as opposed to expansion.
No, we can't.
Of course we can. What? Well, of course we can do a second take, Neil. This isn't the theater. Let's just take it back. What? No, say that again. You only rented the booth for 2 hours? Good God, man, why? Well, how low is the bloody budget, Neil? Oh, you absolute rube. I hate you, Neil, you know that? I hate you so much. No, fine, that's just fine. We'll just go on with the word explansion in there, shall we? Perfect, where was I? Page 3. How do you pronounce that? Inflations? You sure about that?
Yeah.
It's fine if I can just pronounce it however I want if we're keeping explansion in there. I could say infilations. You get it, Neil? Like a blowjob. Infilations. Is that good? Perfect. Brat. As the universe expanded, the intense heat stored within the singularity began to dissipate. The rapidly declining temperature soon led to energy decay, creating particles now known as infilations, which we now know not only continue the expansion of the universe, but have in fact accelerated the process. Less than a second after the Big Bang, particles like quark-gluon plasma, newly created by colliding infilations, began to aggregate with participant particles, creating the universe's first atoms, the building blocks of creation.
What are you doing?
I'm making a drink, that's what I'm doing. You have a problem with that?
Well, we only got a couple hours.
Yes, Neil, I'm aware of the time limit. I consider it stressful. So if you want me to get through the rest of this script, it's happening on my terms, damn it. Thank you. Now shut up, jackass.
I just think, you might not be able to read on the road.
Oh, please, I did a 6-week run as Hamlet, sloppier than a Brighton house. I think I can get through a script. Certainly one as dumb as this. For the next few million years, well, everything was a bit boring, actually. In its infancy, the universe was nothing more than an opaque fog, filled with hydrogen atoms, drifting through the mist, rarely, if ever, colliding with the kind of force necessary to trigger further chemical reactions. But, as we have seen, creation is a patient being. Eventually, within the great expanse of time and fog, two hydrogen atoms finally collided with gusto, and the first star was born. The earliest stars in the universe shone 10 million times brighter than our own sun does today, but even this was inadequate to pierce the dense hydrogen mist that separated them. Time marched on, and within these brilliant blue stars the first heavy metals were created and then expelled forth into the opaque mist, where they would eventually collide with other members of the increasingly diverse atom population to create even more stars as solar radiation slowly but surely ate away at the mist until the universe was transparent at last. Millennia ticked away across the cosmos, and then, 4.6 billion years ago, our sun was born. You don't think that sounds a bit self-important, Neil?
Well, I mean, it's kind of what's
No, of course. Billions upon billions of square light years. Naturally, nothing exciting happened until our particular corner of it came along.
No, square light years.
What? Of course that's right. It's a unit of distance, isn't it?
No, I don't
A
think.
square light year. If a light year works in one direction, if you do it in two directions, it's a square. That's how maths
Can we
happen.
get back to the script, please?
Right, the script. Where were we? Mustn't deviate from the script. Mustn't ruin your brilliant script, Neil.
We're doing a great job.
Thank you. While some scientists have dedicated their lives to unraveling the secrets of the universe and its origins, a decidedly more morbid sampling of academics have made it their mission to speculate the nature of the universe's end. I'm paraphrasing, Neil. Calm down. What was that? No, I thought not. Coward. While it may all be nothing but speculation, the eventual end of the universe has been a topic of great interest since man first learned he was mortal. To date, there are three major prevailing hypotheses, each named with the same juvenile enthusiasm with which one would write a comic book, commonly known as the heat death of the universe. The Big Chill is the most widely accepted hypothesis regarding the universe's eventual end. Advocates speculate that the universe's continuous expansion will eventually reach a point where there will simply be too much empty space for heat levels to fluctuate anywhere in the cosmos. The unfathomable coldness of space will reach depths never before seen on this planet or any other. Absolute zero, which incidentally is my nickname for Neil. The Big Rip. That wasn't even my line, that's just a header. You should format your script better, Neil. While it may sound like a sophomoric nickname for flatulence, the Big Rip is the second most widely accepted hypothesis as to the universe's demise.
I don't remember what Andrew wrote.
What?
Well,
Well, I didn't name it, now did I? I'm just the underpaid narrator. Now, keep quiet and stay out of my way.
Okay.
All right. The Big Rip hypothesis states that eventually, as the universe continues expanding, the amount of dark energy, the catalyst of universal expansion, will simply continue to grow until a new singularity is achieved by stripping all matter in the universe down to its subatomic particles and scattering them to the endless reaches of the void. The third and final theorem of the end of all that is... Try saying that 5 times fast. The third and final theorem of the end of all that is. The third and final theorem of the end of all that is. The third... Ugh, I hate this. Right, sorry. Twat. The Big Crunch hypothesis suggests the idea of cosmic balance and rebirth, theorizing that the continual expansion of the universe will eventually reach a tipping point and collapse in on itself, forming a new singularity that will eventually give birth to a second Big Bang. Although the crunch is certainly exciting, the theory is losing more and more credibility with the scientific community as further evidence is discovered. Well, isn't that just keen? Even in the vast reaches of space, the idea of a new, fresh start is nothing more than a laughable pipe dream, meant to soothe the masses into a sloth-like state of docility. And tomorrow, and tomorrow, and tomorrow creeps in this petty pace from day to day to the last syllable of recorded time. And all our yesterdays have lighted fools the way to dusty death. Out, out, brief candle. Life's but a walking shadow, a poor player that struts and frets his hour upon the stage and then is heard no more. It is a tale told by an idiot, full of sound and fury, signifying nothing.
What was that all about?
It's Shakespeare, Neil. Have you written anything better than Shakespeare?
I don't know.
I thought not. Now shut up. I'll script his shit.